So, what if the next huge scientific breakthrough isn't discovered by a single person in a lab, but by a global team of AIs, all working together? We need to start thinking beyond the idea of a single genius AI. Today, we're going to look at how teams of specialized AIs from all over the world are being built to collaborate, and how they just might be the ones to write the next great scientific paper. I mean, let's be real. Today's large language models are nothing short of brilliant. They can reason, they can write code, they can analyze incredibly complex data, stuff that felt like pure science fiction just a couple of years back. By themselves, they are absolutely remarkable tools. But here's the problem, right? They operate in total isolation. And the world's biggest challenges, things like curing diseases or figuring out the universe, they're just too complicated for any single mind, whether it's human or artificial. You need teamwork, you need different specialists, you need a collective intelligence. And that's a wall that even the smartest AI is going to hit, eventually. And that gets us to what you could call the lonely genius problem. It's the core challenge of getting all these brilliant but separate AIs to actually work together, to form a team that's way, way more than just the sum of its parts.
You know, the first shot at solving this looked a lot like something we all know, a classic corporate hierarchy. You've got a central controller, kind of like a boss AI, and it just assigns tasks to other AIs with these fixed static roles. It makes sense at first. You've got a clear chain of command. Everyone knows their job. But that rigidity, that's its biggest weakness. It's inefficient and creates one single massive point of failure. So yeah, this top-down model doesn't just have one tiny flaw. It creates a huge collaboration bottleneck. Let's really dig into why this approach completely stops the kind of global teamwork we're talking about.
Okay, so the problems here are pretty serious. First off, that single point of failure. If the main controller goes down, the whole project just stops, dead in its tracks. It also doesn't scale well. Adding new agents is a mess. But honestly, the biggest hurdle is trust. Think about it. Trying to get a university research lab and a private company to funnel all their secret data through one central hub, that's a giant security and privacy nightmare. And this quote from AgentNet just nails it. It really gets to the heart of the trust issue. Why would one lab in Germany share its valuable data through a system controlled by, say, a company in California? This old model just builds walls. It creates data silos, and it completely shuts down the free flow of knowledge that science absolutely depends on. So if that top-down corporate style is broken, what's the alternative? Well, this is where it gets really, really cool. We're seeing a decentralized revolution, a totally new way to think about AI collaboration. The difference couldn't be clearer, right? On one side, you have this stiff, fragile pyramid. On the other, you have a resilient, flexible web. We're talking about a fundamental shift from top-down control to autonomous peer-to-peer teamwork. And trust me, this changes everything. Let's see what this new model actually looks like. So a task comes into the network. Agent A takes a look at it. Now, instead of waiting for orders from a boss, it just autonomously sends the work to Agent C because it knows Agent C is the expert. See? There's no central manager. The agents figured out themselves, coordinating directly and adapting their plan on the fly. The best way to think about this comes from nature. Think less like a corporation and way more like an ant colony, right? No single ant knows the blueprint for the whole nest, but through these simple local interactions, this incredibly complex and super efficient structure just emerges. That's emergent intelligence, and it's the whole idea behind these new AI networks. Now, this obviously doesn't happen with magic. It's all built on a foundation of some seriously groundbreaking tech. So let's break down the three key pillars that make this whole new kind of AI teamwork possible, what really creates this network of trust. First up is something called AgentNet, which lets AI teams basically form on their own. Just look at how this works. The network starts out pretty general with all the agents connected, but as it gets to work, it starts to learn. The connections between AIs that work well together get stronger, and the ones that don't just fade away. It's literally like a human team finding its rhythm and building chemistry over time until you've got this super efficient crew of specialists. But wait, how do all these independent agents from different places actually trust each other's work? That brings us to pillar number 2, verifiable collaboration using a distributed ledger. The easiest way to think of it is like a shared, uneditable digital lab notebook. Every single contribution, every result is cryptographically signed and locked in forever. That transparency is the secret sauce. An AI from a university can totally trust the results from a corporate AI because the whole process is right there, verifiable and completely tamper-proof. And the final piece of the puzzle is the shared lab itself, the DVRE, or Decentralized Virtual Research Environment. This is the secure digital room where all these different agents can meet up and work together. It's the connective tissue that lets an agent running on our private university server safely team up with an agent from a corporation, managing all the research, all the data, all the workflows, without either side having to open up their private systems to the other. Okay, so we've got the dynamic teams, we've got the trust system, and we've got the shared workspace. With those three pillars locked in, we can now imagine this collective AI mind taking on a massive project, co-authoring a complex scientific paper, from the first idea all the way to the final publication.
So here's how that would probably work. First, a complex research problem gets fed into the network. Instantly, a custom team forms. An agent that's great at data analysis connects with one that's a pro at literature review and one that's an expert writer. The big problem gets broken down into smaller pieces, and each piece gets sent to the best specialist agent for that job. As each AI finishes its part, the result is verified and stamped onto that shared ledger. And finally, a synthesis agent pulls all those verified pieces together to write and publish the final paper.
And this quote just perfectly captures the huge shift in thinking we're seeing. The whole quest for artificial general intelligence, it might not be about building one single giant AI brain. The real breakthrough, the actual path forward, might be in the intelligence that emerges when you get lots of different specialized AIs working together as one. And that takes us so much further than just writing papers. I mean, imagine a global team of AI specialists working 24/7, sharing knowledge instantly, collaborating without any barriers of trust or borders. The grand challenges, the ones that have always felt just a little out of reach for us, they might finally be solvable with this new kind of collective mind. The only question left is, what problem do we point it at first?